Alright, so to wrap up on Chapter 3, we're going to finish up by looking at regular expressions. So a regular expression, or just a regex for short, is going to be defined by, or is going to be used to define a rule set for a search pattern that we are looking through a string for. So the process of analyzing strings with a regex is going to be known as applying the regex to the string. So regular expressions are used to either match or replace the contents of a string. For the examples that we're going to be discussing, I'm going to be using this really simple example, and then we'll introduce another more complex example. We're only going to be concerned with the matching behavior, so we'll just focus on that. So regular expressions are compared against strings using the pattern class. So this pattern class is something else that comes from the util package, but more specifically, there's going to be another package contained inside of that, which is going to be the Regex package. So that's where we're going to get the pattern class from. And once we actually have imported that, we can go ahead and put together two strings. So one of these strings is going to be for whatever pattern we're looking for, and then another string is going to be some kind of statement or phrase that we are looking through for that pattern. So in this case, I've created a pattern and a statement that are exactly identical. So basically, I'm just trying to make sure that my statement matches perfectly with my pattern. We can then go ahead and create a Boolean. I'm going to call this Boolean Match in this example, and this is where we're going to use the pattern class. We're going to use the matches method from that class to compare our pattern and our statement. So we can actually go ahead and put together this little piece of code to see how all of this works. So we'll go ahead and minimize this. We're going to come over to NetBeans, and right here we'll go ahead and create a new project. We're going to make a new Java application. And for this one, we'll go ahead and call this our, let's say, regular expression. Go ahead and click Finish. And so right here, we'll go ahead and remove the extra comments that we don't need. For this part right here, we're going to go ahead and put in that import statement. So we're going to be importing from the Java library. We go into the util package. From that util package, we want the regex package, and from that regex package, we're going to want the pattern class. So we're going to go ahead and grab this, and then finishing up inside of the class body, go ahead and continue to remove some comments and adjust the style of this a little bit. And so right here, we'll go ahead and put in our two strings. So the first one was going to be for the pattern that we're looking for. So let's go ahead and call this one pattern. This is going to be equal to the phrase hello world. We'll then have a second string for the statement that we're scanning. This one can just go ahead and also be hello world. And then finally, we want to go ahead and include our Boolean. We can go ahead and just call that match. This is going to be equal to the comparison using the matches method from the pattern class. So we're going to put pattern.matches, and then we're going to put in our pattern and our statement. And save that. And so then if we wanted to, we could go ahead and check to see whether or not match returns true or false. So let's go ahead and put in a single print statement right here. So we'll do system.out.println. And right here, we'll put in match. We'll go ahead and save that. And if we go ahead and run this, we can go ahead and see that it prints out true to the console right there. So we can see that these things match with each other. And then if we wanted to, we could go ahead and remove maybe just a single character from our pattern and see what effect that has. So if we go ahead and run this, we see that now we get false because this phrase does not match up with our statement. So even though technically this part matches with this part right here, the way that we set up our pattern is that we're trying to make sure that this pattern is exactly the statement itself. And since that's not the case, we're going to get false for that. Get back. So ideally, whenever we're dealing with our patterns, a pretty useful thing is to be able to check for just a portion of, say maybe just a single word in an entire sentence that we could look for, or maybe we're looking for a single character, maybe a particular letter of the alphabet that's inside of our statement. So in order to do this, we would need to introduce some more complex components or pieces for our pattern. So this is where we're going to get into things like our matching characters, some meta characters, and some quantifiers. So let's take a look at each one of those. So the way that I'm going to approach this is I'm going to go through some tables for each one of those different concepts within our regular expressions. I'll talk a little bit about what each of the different elements that we're looking at, what that actually means, or what that can do for you in your regular expressions. And then at the very end, we're going to go ahead and take a look at a more complex example that utilizes a couple of those in order to check for a more robust or more versatile pattern. So the first table we're going to look at is going to consist of the common matching characters that we can use in our regular expressions. So this is going to include things like this dot character, so just a period. This is going to match with any character, so it doesn't matter what character you specify. If you put a dot right there, that's going to match up with anything at all. So it's essentially like a wildcard character. We then also have a caret, so that's going to be the character that's just above the 6 key, as well as a $sign. So these two characters are used to match the beginning or the end of a line. Essentially, if you've got a string that you want to do some comparisons with, at the very beginning of that string is where you would expect this caret character to be, and at the very end of that string is where the $sign character would be. In addition to these, we also have these set definitions. So this pair of brackets is what indicates a set definition, and then the things that you put inside of it are the different possible options to choose from in that set definition. So this allows for a match to any one of those characters, so it could be one or another or some other. In this particular example, we have A, B, and C inside of our set definition, so that means that we could have a match on A or B or C. Alternatively, if we have a set definition and we put that character or the caret inside of it, the meaning for that caret will now change to be a negation of your set definition. So in this case, it's going to mean that we only have a match if it is not one of those characters. So this says that we cannot match A or B or C. Alternatively, you could describe this as a match for anything except A or B or C. Additionally, inside of our sets, we can have this hyphen character. This is used to specify a range. So in this case, we see A hyphen D. That means that we can have a match for anything from A to D. So this would include A or B or C or D. Another way that we can kind of describe that same sort of behavior of having a match on one thing or another is to use a single pipe character. So you can think of this kind of like your logical OR from your Boolean expressions with your logical operators. So a single pipe character is used in regular expressions to say that we want to match either one thing or another thing. In this example, we're doing either A or B. If we have either of those, then that's going to be a match. This next table is going to be for our meta characters. So the meta characters are essentially used to describe a very large range of different values. So to give you an example of this, we've got this \D. This is the meta character used to represent all of the numeric values we could have. It's essentially for any digit 0 through 9. So we can see right there in the description, another way to represent this is if we had written a set definition with the range 0 through 9. Alternatively, we're going to have a slash, so we have \, and then D. So this is going to be the inverse or the negation of the previous meta character. This is going to be a match for any non-digit. So this is again using that set definition, but now we're including that caret inside of it to indicate that it's negation. So this will only match for any character except 0 through 9. Our next one is going to be the \S. This is used for any white space character. So that includes things like tabs, new lines, maybe a single white space. \, and then a S is going to be any non-white space character. So if we do that set definition and we put in the meta character for white space characters, we just want to include that caret to indicate logical negation. The next one is going to be a \, and a W. This is for word characters. So this includes things like lowercase or capitalized letters. So we see that range A through Z, and then again capital A through capital Z. We also include the underscore, and we include the digits 0 through 9. So essentially a word character is any alphanumeric character and underscore. So any one of those would be a word character. Backslash and a capital W is going to be any non-word character. So this is just the inverse or the negation of the word character. And then finally we have backslash B. This is going to be for what is known as a word boundary for your word character. This is basically describing the boundary between any white space. So you see the backslash S indicating white space and a backslash W indicating any word character. So the boundary is essentially the, you could also think of this as the end, so the opposite would also be true. So it's essentially the beginning and the end of a word. Those make up the boundaries of that word. And then finally for this last table, we have our quantifiers in irregular expressions. So the first example we have right here, we see that we've got the character A. So that's going to be the character that we're actually interested in matching. And then we have a pair of curly braces. And inside of there, we are going to put a number. So right now I'm representing it as X. And that X is going to be the number of times that that character needs to show up for there to be a match. So in this case, let's say maybe we use X as 3. Then we only have a match when we have A. In the next one, we're going to kind of expand on that by including 2 different values. So we have a comma-separated list of an X and a Y, where essentially this is going to be the range of different amounts we could have. So maybe we do something like 3 to 5. So if we have 3 A's, that's a match. If we have 4 A's, that would be a match. Or if we have 5 A's, that would also be a match. If we do this A star, this indicates that A must occur 0 or more times. We can also represent this using the previous syntax for a quantifier, where we've got that pair of curly braces. We have a 0 for the lower bound, then a comma, and then we have nothing for the upper bound, which indicates that that is boundless, so that could just keep going to infinity. If we do an A plus, this indicates that A must occur 1 or more times. So this is basically saying that as long as we have at least 1 A, we could have any number of A's. Besides that one rule, we have to have at least 1. In this case, again, using the pair of curly braces, we've got a 1 for the lower bound, and then a comma, and then nothing for the upper bound, again, indicating that this is boundless and can just go on to infinity. If we have a question mark that immediately comes after a character that we want to try to match, so like in this example here we have A question mark, this is going to indicate that A should occur either 0 or 1 times. So it's basically saying we either have an A or we don't have an A. And again, if we use the pair of curly braces to represent our quantifier, this would basically be 0, 1. Alternatively, if we use the question mark after one of these other quantifiers, so in this case we're doing A, and then a star, and then a question mark. In this case, the question mark is used to refer to what is known as a reluctant qualifier, which means that it's going to stop on the smallest match. So in this sense, it's reluctant in the same way that a lot of people are reluctant about working, where they will just do the bare minimum and then just stop there. So in this case, it's just going to match on whatever the smallest possible sequence of characters it could find happens to be, and then it will stop there. So now that we've gone through these couple of tables and we've described a little bit about each one of the different matching, meta, and quantifier characters, I want to take a look at another example that's going to use a combination of each of those in order to create a regular expression that can be used to match any valid phone number, or at least the majority of valid phone numbers. So for this use case, we're going to account for the optional use of hyphens, spaces, and area codes. So that means that we need to consider the possibility of whether or not the user will put a hyphen or a space in between certain sets of digits. So usually you'd see something like, if they include an area code, it would be 3 digits, and then a hyphen, another 3 digits, a hyphen, and then 4 more digits. Or it could be that same combination, but instead of hyphens, they use spaces. Or for some people, they'll even just combine all 10 digits together. Alternatively, the area code might also be optional. So in some cases, if it's a fairly local number, you might leave the area code out and just have the 7 remaining digits. So we've got a couple of different combinations to consider here. So there's a couple of rules about how we're going to put together our regular expression, so the pattern that we're going to be checking for, that we need to keep in mind. The first one, right here, since the backslash character is used to indicate an escape sequence in a string, but we want a literal backslash to indicate a meta character, the regex is going to require 2 instances of the backslash to indicate that it's meant to be interpreted as a literal backslash. Additionally, we're going to be using parentheses in a regex. This is going to be used to indicate a grouping. So these are not literal parentheses. This is instead just part of the syntax of our regular expression. So the question mark that you're going to see after the pair of parentheses is being used to check if the 3 digits for the area code are actually included or not. So let's go ahead and type out this pattern in another example, and I'll kind of slowly break down everything that's going on with it. So we'll go ahead and minimize this. We're going to go ahead and come over here, back into NetBeans, and we're going to go ahead and create another project. So this will be another Java application. Go ahead and click Next. For this one, I'm going to call this my phone checker, or I guess we'll call it the phone number checker. So we'll go ahead and click Finish. So right here, we'll go ahead and remove the extra comments. We'll again make sure that we have that import. So we're going to be importing java.util.regex.pattern. Since we're still going to be using this later to match up the statement that has our phone number with the pattern that we're going to create. And then right here, the first thing we'll go ahead and put in is going to be our pattern. So we'll go ahead and do a string. We'll call this pattern again. So this is going to be equal to the string literal that holds our regex expression, so our pattern that we're looking for. So the first thing I'm going to put in is going to be the pair of curly braces. And this pair of curly braces will contain the grouping for the area code, since we're going to be specifying that they either will have the area code or they won't. So there's going to be 3 digits we have to account for. So the first thing I need is my literal backslash. So we have 2 backslashes there, and then the D indicating that it could be any digit, so anything from 0 through 9. So we're relying on meta characters to do this. I'm then going to put a quantifier right next to it. And this quantifier is indicating that we must have 3 digits. And then for this entire thing right here, we'll put a question mark, which basically says this entire group, we either will have it or we won't have it. So we'll either have 3 digits or we'll have no digits for the area code. The next thing we're going to need is going to be a set definition. So the set definition is to indicate that we could either have a hyphen or we could have a space. So they could either put a hyphen or a space in between certain groups of digits, or they could also not do either of these. So again, we're going to have a question mark. So this could also be optional. The next one we're going to have is going to be for the next group of 3 digits. So this is the part where we get into these 7 digits that are used besides the area code. So these are going to be the 7 required digits. You have to have these for a valid phone number. So we're not going to be doing this grouping because we don't need this this question mark here to indicate if that's optional. It's not going to be optional. So again, we're going to have our 2 backslashes and then our D to indicate that it's any digit. Again, we have a group of 3 of these, so we're going to specify that we must have that group of 3 right there. The next thing we'll have is going to be the other hyphen, space, or nothing. So we're going to have another set definition. Inside of here, we're going to have our hyphen or our space. And then for the next part, we'll go ahead and just put a question mark, so they may or may not have either one of those. And then finally, for the last part of this, we're going to have the remaining 4 digits. So again, we're going to specify the meta character for any numeric digit. And then we're going to specify the quantifier here as 4. So this whole expression, this whole pattern that we have right here is going to be used for any valid phone number. The one thing that I'm not going to account for in this is going to be parentheses. So if we double check over here, you'll notice that I make a note about this. So since parentheses require a matching opening and closing pair, this is a little bit different from the kinds of patterns that we can look for using regular expressions, and it's going to be beyond the scope of what you could accomplish with most regular expressions. Instead, some additional pattern matching techniques are going to be necessary to check for parentheses that are a bit beyond the scope of what I want to cover for this. So we're going to go ahead and disregard that portion of it. Besides that, this will be good for any valid phone number. So in addition to my pattern, the next thing I'm going to need is going to be the actual phone number. So for the actual phone number, since it could be a combination of digits, spaces, and hyphens, I need to treat this as if it were a string because we have some characters that are not numbers. So the way I'm going to do this is I'm going to create a string called phone number. I'm going to initially make this an empty string, and for the next part, what I'm going to go ahead and do is add in the scanner class so that the user can actually input their own phone number for this and test it. So we're going to go ahead and import the scanner class as well. Do that right here, java.util.scanner. So make sure that we're getting the scanner from that util package as well. Right here, so underneath my two strings, I'll go ahead and make that scanner as well. So I have a scanner that's going to be equal to a scanner that we can call keyboard, and that'll be equal to a new scanner object. And this is going to be reading from the keyboard input, so we're going to be using system.in. And then the last thing I'll go ahead and include is going to be my Boolean, we'll call it match. For this one, I will initially set this to false, and then in a moment we'll go ahead and assign it with the matches method. So the next thing I need is going to be a print statement requesting that the user input their phone number. So I'll say system.out.println. Let's do print. We'll say please enter your phone number. We'll then go ahead and read that off using the scanner method. So we're going to be using next line to get that, and we'll be storing that in phone number. So we're going to do phone number is equal to our keyboard.next line. And then after we get the phone number, we can go ahead and do this comparison. So we'll go ahead and just do match right underneath it. So we're going to say match is equal to our pattern.matches. And right inside of here, we're going to put in our pattern, and we're going to put in the phone number that we just got. And then the very last thing we want to do is to essentially check if match is true or not. So if match, so we're going to say if match is true, we'll go ahead and print out the statement right here, which says the phone number is valid. Otherwise, so let's just say else, we'll go ahead and print a different statement saying the phone number is not valid. So we'll go ahead and save that, and then we'll go ahead and run this and test it out. Okay, so we can go ahead and enter our phone number. So let's start off with the smallest case. So the smallest case would be if we did just the last 7 digits, so we leave off the area code, and if we also don't put any hyphen or space between them. So if we do something like just 1, 2, 3, 4, 5, 6, 7, this should be a valid phone number. So we see the phone number is valid. We'll then kind of add on to this by just expanding it slowly. So we'll do this again. We'll do 1, 2, 3. Let's do a space this time, and then 4, 5, 6, 7. See the phone number is still valid. Do it once more, 1, 2, 3. This time we'll do a hyphen, and then 4, 5, 6, 7. And we see the phone number is valid. Next, we'll go ahead and incorporate the area code. So for this one, let's do just everything kind of all mashed together, so no spaces or hyphens. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So just all 10 digits. We'll run that. That phone number is also valid. Let's try this. We'll do 2 more cases. We'll do one with hyphens in both places and then one with spaces in both places. So we'll do 1, 2, 3. I guess we'll do hyphens first, 456, and then 7890. Phone number is also valid. And then finally, we'll go ahead and do 123 space 456 space 7890. And that phone number is also valid. So we can see for each one of these primary cases, it looks like our phone numbers are valid, so that's good. We'll also go ahead and test it just once with an invalid phone number. Let's say we do just 6 digits, so just 1, 2, 3, 4, 5, 6, and it'll tell us that this phone number is not valid. So this is not really an exhaustive testing of it, but it looks like based on the few cases that we did try, that this is working the way that we intended for it to. So at this point, this is going to conclude everything for regular expressions, and this is going to wrap up everything for Chapter 3.